In this video, we're going to be deriving the quadratic formula. The quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. The quadratic form is ax squared plus bx plus c is equal to 0, and we're going to start with that. And we're going to employ completing the squares to obtain this formula. So ax squared plus bx plus c equals 0. We divide by a. So we get x squared plus b over ax plus c over a equals 0. Now we take half the coefficient of the x um, variable, x plus b over 2a squared. Okay, when we do this, when we square this, we're going to get x squared. When we multiply this out, we're going to get x squared plus b squared over 4a squared plus b over ax. Okay, because a half plus a half is going to equal b over a. So now we need to subtract out b squared over 4a squared because that was never part of the original equation. And then we have a plus c over a, and this is equal to 0. So we now isolate x plus b over 2a squared. That'll equal minus c over a plus b squared over 4a squared. Okay, now we will take the square root of both sides. So we're going to have x plus b over 2a, and that will equal plus or minus the square root, and I'm just going to put b squared over 4a squared minus c over a. I just swapped the terms, that's a minus. So now I am almost done. I subtract minus b over 2a, and on the right I still have plus or minus, and now I'm going to get the common denominator. So I'll have b squared minus 4a squared, which will be the common denominator, minus, and I'm going to multiply the right side by 4a, so it'll be 4a times c, so that I can put it over 4a squared. So that gives us again x is equal to minus b over 2a plus or minus. Now the square root of 4a squared is 2a. Okay, so I can pull out 2a. So it'll be 1 over 2a, and then I'm going to have the square root of b squared minus 4ac. So now we have the common denominator is now 2a. So I have x is equal to minus b plus or minus square root of b squared minus 4ac, the whole thing over 2a. And I've just derived the quadratic formula. We're going to have two roots. So every parabolic curve will have either two real roots or two imaginary roots. In this case, I just gave an example, and the roots are where the curve touches the x-axis. They're going to be the x-intercepts. I gave two parabolas, one upside down and one right side up, and it's also the upside down parabola will also have two roots. Okay, so I've shown two parabolas, one right side up, the other one right side down. Each of them have two x-intercepts. And in this case, they have real roots. If they don't have real roots, then the curve will not be touching the x-axis. It will be floating above the x-axis and then floating below. Those are for imaginary roots. But you can get real and imaginary roots using the quadratic formula. So we employed a process called completing the square. Just to recap, we completed the square. And completing the square is often used actually in solving for the roots. I encourage you to review the videos that we have on completing the square. So it's important to understand that the quadratic formula should not be a black box. You should know exactly how it came about instead of just using it blindly. Thank you.